So this week we continue looking at bias in data. I hope you had a chance to listen to the class lecture already where when I reviewed the concepts. Now we're going to use SPSS to determine if there is bias in our data. So one way, the first thing that we're going to do is open up our data set. So if I go into additional resources, I can pull up this download festival file. Chapter 5 refers to this data set. So let's go ahead and open this up. Yes. And there's different ways to determine whether your data are normal. I talked about this in a class lecture. We can use numbers to determine this. We can use graphs to determine this. So the first thing that I want to do, let's use graphs to spot any normality, to determine normality of our data. The first thing we're going to use is a PP plot. So here is our data that I pulled up. Here are our different variables: gender, day 1, day 2, and day 3. So we're looking at people's hygiene during these days. And let's look at variable view. This will give us a better idea of what these variables are. So again, this is each participant's ticket number, gender. We have gender of concert goers, and this is how our gender variable is labeled. 0 denotes male and 1 denotes female. So day 1, each person's hygiene. Day 1 of download festival, their hygiene score was given for day 1, and again for day 2, and again for day 3. And notice these are scale. Okay, gender is our categorical variable, so we select nominal. Ticket number is scale, as well as our gender. As well as hygiene, our hygiene scores. So now that we're familiar with each of the variables, let's go back to data view. And as you can see, these little dots denotes missing data. So you can see that all of the participants, we have their hygiene score for that first day. But you notice that we have much less on day 2 and even much less on day 3. So we have quite a bit of missing data here. And we're going to look at that in just a few minutes, what we can do about the missing data. So first thing we're going to do, let's use a graph to spot our normality. So we're going to create a PP plot, which is a probability plot. It's a great way to visually we have a great visual to check for normality. And to get a PP plot, the first thing that we're going to do, we're going to click on Analyze, and then Descriptive Statistics, and then PP plots. And we want to examine the normality of each of these variables. So what I can do, I can click on hygiene, press my shift button, and then click at the bottom on day 3 of hygiene. So like that, it will highlight all 3 at the same time. I can click my little arrow here. So I have all 3 of my variables. And notice our test distribution, we want to test the normality of our data. So let's see what this looks like.
One thing that I noticed, and I hope that there's minimal confusion here. So there are several places where there's errors in the textbook. I'm sure some of you had noticed it in chapter 3 whenever we were entering the data for chapter 3 when you were getting familiar with SPSS. This is another instance where your SPSS output may be different than the textbooks. I know mine is. So let's look at, in order to examine the PP plots, I want to look at normal PP plot of hygiene. Not the detrended normal PP plot, but the normal PP plot of hygiene. This is day 1. And if we want our plots to fall as closely as possible along this diagonal, and if you look on page 182 at day 1, their line looks much more diagonal, much straighter than ours does. And so did my lecture. My lecture actually came from the textbook, portions of the textbook, and I used those images to show that day 1 was normal. But now that I'm plotting it, as you can see, this is definitely deviating from the diagonal line. And let's look at day 2. Wow, day 2 is also skewed. And let's look at day 3. Day 3 again. So day 1, day 2, and day 3 all look non-normal. So if based on what we think, so what if you're just not quite sure? So what if you're looking at day 1 and you're saying, well gosh, this is pretty close. Maybe it's close enough that the data are normal. One way that you can determine this, an easier right and wrong answer, graphs are kind of a gray area sometimes, especially whenever it's really close, especially when you're talking about normality. Sometimes it may seem that it's not normal, but actually it is, or vice versa. So let's use numbers to spot normality again, and that will definitely help us get a better indication of whether these data are normal or not. And especially whenever you're using smaller samples. When you're using graphs are great if you have large samples, but smaller samples, it's better to use the frequencies command. So let's go back to our data file, our data view, and let's go to Analyze, Descriptive Statistics, and Frequencies. Now again, we want to move all 3 of our variables over because we are examining the normality of all 3 days. And we also want to click on Statistics. And these are the options here. So frequencies. So for instance, if you want to examine just the descriptive statistics of a particular variable or variables, this is where you would go. Notice all of your central tendencies are here, your central tendencies of measure, mean, median, mode. We have our standard deviation, variance, range, skewness, kurtosis. So you can click on any one of these options, any or all of these options, and this will create a chart showing those descriptive statistics for that particular variable or variables. So for this particular instance, we are going to look at the mean, median, mode. Let's click on standard deviation, variance, range. Now, to check to see if our data are normal, let's click skewness and kurtosis.
We'll click continue. And we will click OK. You know what? One thing that I did forget to do, let's go back to Analyze, Descriptives. Let's see, we were in Frequencies. Let's go to Charts. We'll also create a histogram of our data. And we want to show the normal curve on our histogram and see what that gives us as well. Let's go up and look for, here we go. This is what I'm looking for. Here, this is what you would look for if you're looking for descriptive statistics. So basically, if you had to describe, if you had to interpret what your descriptive statistics would be, for instance, if I'm looking at hygiene of day 1, I would say that the median for, so we have a sample size of 810, which our sample size, as you can see, goes down as each day of the festival continues. And so, and we have no missing data as well. The mean of this data is 1.79, and notice the median is also 1.79. So think about it. Remember, if there were any outliers in this data set, that would skew the mean. Your mean and median would probably be very different, but they're the same. So your data, there's probably no outliers. Okay? It gives you the mode, the standard deviation. The standard deviation is pretty small, so there's not a whole lot of variance in your data. It also gives you the skewness and their standard error of skewness. Now these are the numbers that you're going to use. Remember in my class lecture when I talked about calculating those z-scores for skewness and kurtosis. Going back to page 184, you're going to use that formula, that skewness formula, the z-score, the skewness z-score and the kurtosis z-score. You're going to use those formulas on page 184, and that will help you determine if there's a problem with kurtosis or skewness. And so again, this is where you would find your numbers. But this is where my numbers are different from the book's numbers. So for my skewness, I have 8.865. I'm looking at page 183. My skewness is 8.865, and the book's is negative 0.004 for day 1. However, my day 2 is the same, and day 3 is the same. Now, same for, well, however, my standard error of skewness is the same. 0.086, 0.150, and 0.218. So there's an error somewhere. The book has an error somewhere, because I've done this a few times and I keep getting the same number. So I'm assuming that the book has an error here. So again, this is how you would use your descriptives in order to get your frequencies, and this is where you would get your skewness and kurtosis numbers as well, your skewness and kurtosis statistics. So, using these numbers to calculate your skewness and kurtosis z-scores, that's one way that we can use the numbers to determine the normality of our data. Another way is by using the KS test.
So let's go back to our data view. And now let's complete a KS test. So if I go to Analyze, Descriptive Statistics, and Explore, again, I'm going to place all three of my variables in my dependent list. Remember that the dependent variables are our outcome variables. And then we're going to click on Statistics. And it's just going to give us our general descriptives. This is our default, and so that's fine. So we'll just click Continue. And then let's click on Plots. Now we want to select Normality Plots with Test. This is the option that you need to choose in order to look at your KS test results. So let's click Continue. So let's go ahead and click OK. And this is my test of normality here. Test of normality, this is our KS test. This gives us our KS statistic right here. This is the DF, the degrees of freedom, which would be your sample size. And then we have our significance values for each of these days. And for some reason, let me go back. So here is where I was talking about missing values, how we're going to deal with missing values. Because remember, we had looked at the data set and we noticed that we had over 800 participants there. We had over 800 people's hygiene scores on that first day, but our DF here, which would be our sample size, is showing much less. It's actually showing the same number of all 3 days, and we know that that's not right from looking at our data set. So we need to go back. Let's go back to Descriptives and Explore, and now let's go to Options. Everything else is still in here, but we forgot to go to Options. And it's important because although we start off with 810 scores on day 1, day 2 we only have 264, and day 3 we only have 123. So it was only showing us our day 3 individuals. So we are going to actually select Exclude Cases Pairwise. Click Continue, and then OK to run our analysis. Sometimes you have to kind of dig around for your output. Here it is, right here. Perfect. So we have our test of normality. This is our 810 sample size. This is our 264 and 123. So one piece of advice that I could give you, it's always very helpful before you begin analyzing your data. Look through your data set very carefully, especially if it's not your own data set, if it's someone else's data set, or maybe you just need to refresh your memory on the characteristics of your data set. It was because we looked at that and examined the data set first off and noticed that we had so many more participants on day 1 that immediately helped me realize, oh, there's a problem here. So always good to be very familiar with your data before you begin analyzing it.
So my findings is actually a little different from the book's findings. Again, on that day one, there's something with day one that there's a mistake in the book somewhere. So here is our KS statistic. This is our DF. We have a sample size of 810, and this shows that it is significant. So day one, the data distribution in day one is showing that it is significantly different from a normal distribution. And remember, we looked at that PP plot, and I said, gosh, the one in the book looked a lot more linear than the one that I actually got, and this supports my findings. So again, day one, this is telling us that our data are not normal for day one. And the same for day two. Again, it is significantly different from a normal distribution, and the same for day three. So when we report our KS findings, this is what we would use. This is a statement that we can use to report our KS test. We can say the hygiene scores on day one. We have D denotes the KS test. So going back to here, so our little statistic, our little KS statistic, we're going to use D to indicate this test statistic. So we will say D, our test statistic, and then we would put our sample size in parentheses. So D, our sample size, equals 0.083, which would be our test statistic, 0.083, with a p-value of less than 0.001. So yes, our significance shows 0.000, but if you look at journals, if you look at, APA usually indicates if it's 0.000, it's very commonly written as less than 0.001. So that's why I indicated it that way. Now notice, this is our KS test findings are right here, these first three columns. Please don't mistake these three columns for your KS test as well. This is another test that SPSS completed as well. So we're only looking at the results of this. And we wrote, so basically we followed the same format for day two. Day two, this is my sample size. This is my test statistic, my KS test statistic, p-value less than 0.001, and then day three, D, here's my sample size or my degrees of freedom. We have the test statistic, and again, less than 0.001. They were all significant and non-normal. So all the scores on all 3 days were non-normal. Okay? So finally, what about if we wanted to look at multiple groups? If we are wanting to compare two groups and we are wanting to look at the homogeneity of variance, because I don't know if you remember from my class lecture, if you are examining two different groups, one of the assumptions, one of those items, one of the criteria on that checklist, we have to make sure that the variance is similar, it's the same with those two groups. And that's where the Levene's test would come in. The Levene's test would tell us whether those two groups are similar, if their variance is similar. So going back to our data file, what if I want to look at first day's hygiene scores, but I want to compare male and female. And before I even do that, before I compare that, compare males and females, I need to make sure that the variance is the same or similar. I want to make sure that the variance is non-significant for males and females. So we can do this by going again to the Explore option. And let's move we can actually move day 2 and day 3 because we're only wanting to focus on the hygiene of day 1. And then our grouping variable is gender because we want to compare the variance in males and the variance in females. So I'm going to move gender over to factor. And then in order to get the Levene's test, I need to click on plots. And notice this option here, spread versus level with Levene test. And I want to click untransformed because we want to use raw data here. So once I'm finished that, I will click continue and I will click OK to run the analysis. Okay. Again, here are my descriptives, and notice that it divided them up into 2 groups. Here are my descriptives for male, my descriptive statistics for female. So you could actually, if you were interpreting this, you can compare the mean of one group to the mean of the other. Okay, looks like the hygiene scores for females were higher on day 1. Okay, you can compare median, you can compare standard deviation. It looks like there was more variance in the female group. Okay. So if I am looking at, here it is, right here, our Levene statistic. So how do we determine if we want to use mean or median? So again, I think it would go by if there are any outliers in your data set. Notice mean and median are very similar, so you could probably use either. I'm going to go ahead and use mean. And so looking at my mean, and Levene statistics have 2 degrees of freedom because there's 2 groups. So we have our DF of 1. Okay, our degrees of freedom is going to be n minus 1 because there's 2 groups, so that would be 2 minus 1. And then here is our sample size for each of those groups. And this tells me if the variance is significant or not. Because this is greater than 0.05, this tells me that it is non-significant, which means that there are no significant differences between the variances of my 2 groups. Because there are no significant differences, that's a good thing. Okay, variances are the same in both groups, so that means that then I can complete my t-test, for instance. I can complete my next step in order to compare those 2 groups. But again, this is one of those assumptions that you would have to meet before you would complete the next step. So, how would we write our findings for this? So to report the Levene's test, for the hygiene scores on day 1 of the festival, the variances were equal for males and females. So F would be my Levene's test statistic. I would put my 2 degrees of freedoms, 1 and 808. This is my Levene's test statistic of 3.36 with a p-value of 0.07. So this is how we would write our findings. So I hope you're feeling a little more comfortable with the information in chapter 5. Like I said, I know it was a heavy chapter. There's a lot of information in here, different tests, trying to figure out how you determine if data are normal or not. I'm hoping that from the class lecture from part 1 and now seeing it in action with part 2, I'm hoping that you're feeling comfortable determining the normality of data sets. Thank you so much.